Kia ora koutou. This is a request from Zachary for a sequences question from June 2020. It's a really nice question because I think it highlights two things. Firstly, if you're doing a sequences question, there are really only a couple of different formulae that can help you. And this is an arithmetic progression, right? And so basically it's got to come down to doing something where we manipulate this one that gives us individual terms in a progression, and this one that gives us two different ways to find the sum to n terms. But it also links back to what we first did in Year 9. And if you think about that, it makes this question much easier. So we're told that the nth term of an arithmetic progression is this. We've got un is equal to a half times 3n minus 15. Now, if we look at that to start with and have a brief moment of freaking out because we can't see an a, the first term, and we can't see a d for the common difference, then we can jump into some algebra straight away, right? And I'm going to show you what happens if you do that. So we know that un is equal to a plus n minus 1d. So what we need to do is match up some things with that formula. So in here, if we expand out, we get 3 over 2n minus 15 over 2. So doing this purely mechanically, what that gives us now is that if we match that up to this formula here, we get that u of n is equal to a plus dn minus d. We can regroup this into a constant term, which is a minus d, plus dn. And what that lets us see is that the common difference is the coefficient on the n. So I guess what I'm telling you here is that this is really an artificial way to do it, right? But this is just using the algebra and not engaging our brains and putting them back into what we did in Year 9. So this is telling me algebraically that the common difference here has to be the number sitting next to the n. So d is equal to 3 over 2. And then that tells me that a minus d has to equal negative 15 over 2. And we know now that d is 3 over 2. So if I work backwards, that gives me that a is equal to negative 12 over 2, which is negative 6, right? So we can get there doing it like that. And you know, if you're nervous in the exam and that's how you end up doing it, then that's cool. But there is a far, far faster way to get to that point. What we're given here is the term rule for an arithmetic sequence, right? So they've told us that un is equal to a half of 3n minus 15. And I'm going to write that as 3 over 2n minus 15 over 2. Now imagine that you're sitting back in Year 9 maths and you're told, figure out the terms for that progression. Well, it's pretty easy, right? The first term here is going to be 3 over 2 minus 15 over 2. The next term is going up by 3 over 2, right? So it's going to be 6 over 2 here. I'll write it as 6 over 2 minus 15 over 2. So if you just sort of put your common sense maths brain into gear, you'll see straight away here that d is equal to 3 over 2. And that means that we can easily find the first term using the methods that we used back in Year 9. So here we've got negative 12 over 2, and here we've got negative 9 over 2. And so we're going up. When I work backwards, I'm going up each time. So my 0th term, which is one way to think about it, is negative 15 over 2. So in here, we've got a, but we actually don't need that. We need the first term, which is this thing here, right? So a is equal to negative 6. And once we've got those two things out, then this question is really, really easy, right? So I would definitely prefer to see people doing it using this method here, right? Where you're just looking at what you've been given, which is the rule for the sequence. And you're reading off straight away that the common difference must be 3 over 2. And then you're substituting in when n equals 1, what is a? Well, a is 3 over 2 minus 15 over 2, which is negative 6. And now we're good to move on to the second part. We've got to figure out the value of n for which the sum of the first n terms is 84. Right, so the sum of the first n terms can come from either one of these two formulae. We don't know anything in here about the last term, and we usually won't, but we do know that 84 has to equal a half n times 2a, so negative 12, plus n minus 1 times 3 over 2. So if we manipulate this, we're going to get a quadratic. I'm going to do this in quite a few steps. Some of you who are confident will probably go a little bit faster, but be careful not to muck this step up, right? So 168 is equal to n times negative 12 plus 3 over 2n minus 3 over 2, which gives me n times negative 27 over 2 plus 3 over 2n. I'm going to times both sides through by 2, and that will give me 336 is equal to n into 3n minus 27. I'm going to take out a factor of 3. I get 3n into n minus 9. And then I'm going to divide through both sides by 3. And that, I think, is going to give me 112. 112 is equal to n squared minus 9n. 0 is equal to n squared minus 9n minus 112. If I look at that and I can't remember how to factorize, remember they do need to see evidence of how like they need to see factorization. So you can't magically jump to the solution here. A good thing to do is just to do a factor tree. Right, so 3 is not a factor because the digits add up to 4, but 2 is a factor. So let's just go with 2 times 56. Right, what goes into 56? I'm going to pick 7 and 8. I'm looking for two numbers that have got a gap of 9. So this is good, right, because hopefully I'll spot that 2 8s is 16. 16, take away 7 is 9. So my numbers are going to be n here, a plus here, and a minus here. And I'm going to do minus 16 plus 7. So n is equal to negative 7, or n is equal to 16. But in the context, we have to have n is equal to 0 because it's a term number. So the answer here is n is equal to 16. So there you go. I just want to go over a couple of things before you hang up the video. So again, whenever we're dealing with a sequences question in AS, it has to be either a geometric or an arithmetic. There are formulas for each of those. For the arithmetic, you're given the formula for the nth term and for the sum of n terms. So any question is going to come down to manipulation of those two things. And in this case, there was a kind of clunky way to do it where we figure out the a and the d, or there's a use your brain way to do it where we just look at that rule for the nth term and we substitute in the value of n being 1, and that will give me a, and then I can look straight away at the rule and I can see what the common difference is. Or I can do it using a bunch of extra algebra, which is fine if you kind of have forgotten your brain on the day of the exam, which hopefully won't happen. Thanks for watching. Zachary, you are sending in some really great questions, so please keep on doing that. And the same for anyone else who's watching.